prayer lang, Anay, ha? So do you hear that one, ha? So now we are recording our class, and I will ask you to close your eyes for a while. We will begin with a class prayer. So shall we pray, everybody? Our dear Heavenly Father, we are thankful, Lord, for this morning that we can start our class today. It's towards the end of the school year already, oh Lord, and maybe these students are having a lot of requirements. I just pray, Lord, that you will grant them and bless them with strength and with more enthusiasm to complete the remainder of the months, Lord, of requirements and other things. May they continually enjoy also their school, their schooling, their tasks. And may you bless us this morning, even as we have our physics class. We ask everything, and we ask all this in Jesus' name. Amen and amen. So good morning, everyone. Now, once again, no? As a matter of review or running through our discussion, so for this morning, we will talk about the electromagnetic wave. And just to start that one, so let me open this. So we will see or look at a short video clip. And perhaps some of you have watched this, but it's a good way to, again, open our understanding about electromagnetic waves. Now, I opened this one in our announcement, and I believe I assigned to you the performance tasks number 5 already, and you can see it here together with the template and with the simulator. So our FET simulator will allow you to perform performance task number 5. So to those of you who were not able to do this, so we will have this week the performance task, but it will already have its deadline. So Friday is the deadline for this one. If you check the submission date, so kindly perform number 1 already. Now here is our video that will introduce to us our lesson 8. So let me just click this. I don't know if Canvas will allow us to play it here. So let's see. So it allows us to play. So let's listen to this. I think the sound is not shared now. Let me share the sound, ladies and gentlemen. So maybe you've seen Professor Dave quite a number of times. So let's just listen to him now and get more understanding to the concept of electromagnetic wave. So I do hope that you will still learn some more. Even me, who've been watching this, I am learning many things still, despite the fact that it's merely 4 minutes. So let's listen to Professor Dave.
Hey, it's Professor Dave. Let's learn about light.
He knows a lot about the science stuff. Professor Dave explains.
Since we've been able to look up at the sun, we've been aware of light. As darkness is one of very few things that we instinctually fear, we have always bestowed light with godlike properties. But for all of antiquity, we had no idea what light really was. Figures like Newton and Huygens worked with light in the 17th century, but a more sophisticated description of light, which we call classical electromagnetism, was developed largely by James Clerk Maxwell in the 19th century. This theory depicts light as a transverse wave composed of oscillating electric and magnetic fields, which are at right angles to each other and perpendicular to the direction that the wave moves. We will learn more about these fields later. Just like the kinds of waves we have previously discussed, electromagnetic waves have amplitudes, wavelengths, and frequencies. But Instead of different frequencies producing different pitches, like sound waves, different frequencies of electromagnetic waves produce different kinds of light. If the light is visible, these frequencies will correspond to different colors. Frequencies greater than this will exist as UV radiation, X-rays, or gamma rays, and frequencies less than this qualify as infrared radiation, microwaves, or radio waves. All of these phenomena are collectively referred to as electromagnetic radiation, and they can be found on the electromagnetic spectrum. Here we can see all the wavelengths and frequencies ranging from radio waves to gamma rays, and we have found some technological use for all of these in modern society. Even though they seem dramatically different, some requiring things like antennas or other equipment to manipulate, all of them are fundamentally the same thing as the light you can see with your eyeballs. They are just of different wavelengths. All electromagnetic radiation moves at the speed of light, which is about 300 million meters per second in a vacuum, the fastest speed possible in the universe. This is fast enough to get from here to the moon in about a second. And since we know that all waves move at a speed that is equal to their wavelength times their frequency, this product will be equal to the speed of light for any type of electromagnetic radiation. How is it that electromagnetic radiation is produced? To answer this question, we have to learn about electric fields, which are coming up soon. For now, let's check comprehension. Thanks for watching, guys. Subscribe to my channel for more tutorials. Support me on Patreon so I can keep making content. And as always, feel free to email me, ProfessorDaveExplains@gmail.com.
Okay, so we thank Professor Dave for this, and we have no. So from this presentation again, now we learn that we learn about the things about the nature of an electromagnetic wave, no? And one thing that we realize now about electromagnetic wave is that they consist of different frequencies, they consist of different wavelengths, no? And usually when we say the frequency is high, no? So when the frequency is high, then its wavelength is short. Okay, so please remember that now. When we talk about a frequency that is a very high frequency, then its wavelength now for that specific wave is shorter. Now, the shorter is the wavelength, the greater is its energy. No? So energy works with frequency. No? Higher frequency means higher energy, but it has lower or lesser, smaller wavelength. No? Now, if the frequency is small or low, no, very low frequency, then its wavelength is short. No, it has a short wavelength. No? So baliskad. No, so low frequency means shorter wavelength. I don't know. Lower frequency, I mean, has greater wavelength. No, and it will have lesser energy. No. So now this one no, tells us that if we check now the presence of an electromagnetic I don't know a magnetic no field, then there will always be no an electric field that is present. No? Now what we've seen there is that kung may electric field kag may ara nga magnetic field, sila na nga duwa no will come into play and they will be forming no perpendicular nga pagka-create no. So they will be moving no in a perpendicular manner, and they will be transverse ang shape nila, no? Totong do S-like kind of wave, no? Transverse. And this transverse wave now is moving, no, at a speed of around 300 million meters per second. No? So whether it is infrared, whether it is microwave, whether it is radio wave, or gamma rays, no, or ultraviolet, now they all move at the same speed because they are actually, no, they belong to the same kind of wave. Nabilong lang sila sa isa kaklase nga wave. No? But again, no, they are divided into different sections. No? So that's the thing about electromagnetic uh, induction. No? So let's check some slides. No? Okay, so again, now we have the EM waves, no, electromagnetic waves, and we've learned that as a wave, no, it has wavelength, it has frequency, it has amplitude, no, and when we talk about the amplitude, no, when Professor Dave was discussing that, once the amplitude is high or maybe not low, it will also speak about its energy, you know, how much energy a wave is carrying. So usually it is indicated now by the amount of the amplitude of the wave. No? So if a wave is very now is having a very small amplitude, then we would probably assume now that that wave has lesser no, amount of energy now that it carries. No? And it has also frequency, you know, it has also wavelength. So the wavelength is either the distance between two in-phase points are near or are far, no, from one another, and we measure and we assign a value for the wavelength in terms of meters, of course. Now, in this wavelength, no, of our given wave, it comes with varied wavelengths. No, for one wave, guys, no, one same wave, it is producing, no, several types of wavelength. That's why we call it eventually, no, as a spectrum. No, there's a part of that electromagnetic wave that have shorter wavelengths, no, maybe towards the left side, and again the longer wavelengths on another end. No? And this one are the waves that produce heat, no? The ones that are kind of producing amounts of heat. No? The ones with longer wavelengths. No? The ones with shorter wavelengths are the ones with higher energy. No? So you may not sense it, but again, no, it can create a lot of damage on you, no, if it hits on us. No? So like, for example, gamma rays. No? Gamma or cosmic rays or radiation, no? They are kind of they are immensely, no, having a lot of energy, and we don't want to be exposed to gamma or to cosmic radiations. No? So, but again, no, they come in that same wave. No? Now, somewhere useful in between is the visible light. No? Nakita natin dito. No? So, ang visible light, no, travels also at 300 million meters per second, the same as with infrared, with radio waves, or with gamma, no, or with ultraviolet. Parehas na ila speed tanan because we realize that they belong to one and the same wave. But what we can only detect with our eye, no, is the visible light, which is found somewhere, no, in the middle. No? And again, no, because of its specific wavelength, na makita siya nato. No? So light, no, light again is only a tiny part, no, of this, or visible light is a tiny part, no, of this very long spectrum of electromagnetic radiation. We call it as a spectrum again because damo-damo sa sang sections dira. Na? Okay, so what is light? No, light is the visible form amo ning makita naton, no? Nga part sa aton electromagnetic waves kag amo ning makita naton nga energy. We cannot see, no, sound, but of course we can detect it with our ear. No? Now, when we vary the frequency of sound, guys, we hear several pitch. Lain-lain nga pitch, no? Again, frequency and wavelength also goes together. So again, varying the frequency for sound, we hear may ara nga mga low sounds, no, makag may ara nga high pitch sounds. But for light, if you vary, no, the frequency of a visible light, what we will see are colors. We will be seeing colors, no. So may range of wavelength na siya, I think from 400 nanometers to 700 nanometers. Kung ang electromagnetic wave falls within that range of wavelength, then we can see it with our eye, no? But if it is lesser than 400, like 200, 300 nanometers, hindi na siya makita karon, no? Or if it will go beyond 700, no, like mahimo siya nga 1,000 nanometer, then we could not also detect it with our eye, no? So again, the one that we can only see with our eye is when it falls within that range, no? The same with sound, no? Ang sound may ara man nga ma-detect sa aton ear, no? That's what we call as the audible sound, no? May range of frequency na, no, para nga ma-detect sa sang dulonggan nato, no? Beyond or below that value, no, hindi ta naman mabatian sang dulonggan nato, no? So most of the energy that surrounds us, no, is invisible, no? Hindi ta na makita yung iban. What we can see is only the visible light, no? And usually what we see sa sining of visible light, we see it as a white light, no? Isa lang siya ka color, pero actually when we let it, no, pass through a prism, that's the time we realize, oy, damo ni gali siya color. It comes with varied colors, no? But however, now once that light, no, passes through a prism, no, or a glass, no, muna pagkakita na nga damo iya nga color, no? Because again, no, it will now disperse, no? Okay, kung mag-agi siya sa isa ka glass, no? No, however, no, most of the energy that surrounds us, no, other than the visible light, we cannot see infrared, we cannot see microwave, no? Okay, kung nagaluto amo da sa inyo nga microwave oven, you will not see nga, uy, amo ni tsura sang microwave, no? No, you cannot detect it, no, with your eye, no? Now this energy travels in waves, no, made of electric and magnetic fields, no? So we were told, no, that electric field and magnetic fields, they move, no, perpendicular to one another, no? Okay, so amo na ang nature sang aton nga electromagnetic, no wave, no? The electric and the magnetic field is in there, no? Okay, now again, the guy that was able to consolidate, no, or to unify this principle, as they call it, no, is James Clerk Maxwell, no? So si James Clerk Maxwell was, again, no, a very intelligent person, but you will see, no, in his lifetime nga he did not grow old, no, he died young, I think. So kung lang tawo mo da, no, he's not ano, no, ang iya edad, no, when he died, no, if you try to subtract it from his birth, something like the 40s siguro, no, in his 40s, no, the James Clerk Maxwell. But he's a very, very intelligent person, and he unifies, no, and combines together ng electric field gali, magnetic field. They come together, no, and when they travel, no, they develop this thing we call as the electromagnetic wave, and light, no, is a part of that, no. So it's a grand and a very beautiful, no, theory, no. So they call it, no, as unifying theory, no, of physics, no. And again, amo nang mga goals ng physicists, no, that they have to relate, no, one principle with the other, because they believe that these principles do not come as a separate idea, no. They come into play with other things. Now even Newton tried to attempt, no, the theory of everything, no. If you see some videos on YouTube, you will see that Newton in his own, no, tried to combine together, no, gravity with other principles in the universe, no, and he tried to conceptualize this God equation, as they call it in physics, the God equation, no. It's a theory of everything, and he tries to, no, combine all these principles, no, that these principles could never be, no, separate from one another, no. that they have to be interrelated to one another, no? Gravity, no, with other phenomenons there, no? But however, no, until today, I think now they are still looking for how to, no, how to link all those principles together, no? So for the theory of everything of Einstein, no, that is still, no, in the making, no? So not like the one that James Clerk Maxwell has created. Okay, so the light, no, light as a wave, no. So we think of light as, if we think of it as a wave, then it behaves, no, together with the rest of the principles that comes with light, no, that it can reflect, it can refract, no, it can bend, no, it can be diffracted, no, once it encounters ano ni, an obstacle, no, then it will bend around that obstacle, no, and all the other principles that goes with waves, no. So light as a wave, no, is one concept, no, of this electromagnetic radiation, or about light, no. Now another thing, no, that they also link light, no, to is light as a particle, no? That there are ano na, corpuscular, no, particles that are found in light, and then they call it as a photon, no? Now, photons or particles is very different from waves, no? But they realize that light is both, no? Light is not merely acting like a wave, but at some point, no, it can be absorbed in a body. That this thing that is absorbed, no, is considered, no, as the photons of light, no, the particles of light. I think now they've invented nowadays, no, may ara sila nga gin-invent nga very black, no, color or dark color, and I forgot the name of that colored black nga, nga paint, no, nga naobra nila, and it can absorb every particles of light, no, nga photon, no? It can absorb kuno 99.9% of the particles of light. So when that surface is ano na, displayed, guys, no, or exposed, no, under the sun, then no light, no, is reflected back, no. So meaning if you make one thing, no, nga hindi mag-reflect, guys, kung ang isa ka object hindi pwede mag-reflect sang wave, no, then if it absorbs everything, then no, you cannot see it, no? If light will not bounce back, no, so you cannot see it, no. There's nothing that you can see if that surface, no, is not reflecting anything, and you will see it simply as a black color, no? If all the colors, no, that is found in light, no, is being absorbed by a body, you will see the body as black in color, no? Now, paano naman yan natin ma-detect ng isa ka object blue, no? What will happen if the object, no, is blue? Now, if light hits that body, no, and it will reflect, no, ang ma-reflect yung color amo na ang blue. It will absorb all the rest of the colors of light, no, but the color blue is the one that will be reflected, and it will reach our eye, no. Once it reaches our eye, we will perceive that thing to be blue. Okay, so again, no, the reflection of light also, no, comes into play whenever we see, no, a thing, no, of color, no? Now, what if the surface is white, no? Ano karon ko ng surface is colored white? What will be reflected, no? So if a surface is white, then once light strikes that surface, all the light that strikes that surface bounces back. Once it bounces back, no, all the colors bounces back, we will perceive it as white, no? So usually, no, ang white colored surfaces, we will not feel warm, no? Hindi na maginot nga bayo, especially summertime right now, no? Kung nagasuksok ka sang puti nga bayo, compared nga nagasuksok ka sang itom nga bayo, you will notice that you will feel very warm, no? Kung nagalagaw ka sa dalan, no? Nagalakat ka sa dalan, nagasuksok ka itom nga bayo, then you will feel no even more no unease no hindi ka at ease no kay maginot no kay gina-absorb ang tanan-tanan nga color sang light no. So you'll notice, I think dogin butangan nila now they tried to put some temperature no as device, or maybe no a thermometer something no, or a sensor ang surface that is colored black to a surface that is colored no maybe no white no a surface, and they notice no that it's really warmer no, or has more no absorption ang black na color than the white color. And even again on our physical uh, body no, kung i-observe lang siya naton between wearing a white shirt over no a black or darker no, colored shirt no. So much so no kung black gid no. So again no, the nature about light no, so duwa no, there are two principles that governs light guys no, and it is no dual ang iyang characteristic no. So this is it no, so light comes in varied colors. It has a range of frequency of 400 to 700 nanometers no. And again no, that if that falls no within that wavelength, so 400 nanometers to 700 nanometers are wavelengths no. If it falls within that range of value ang wavelength, then we will detect it no as a ano ni, as a visible light no. Other than that no, if it is bigger no, like 10,000 nanometers no, then we will not no, we will lose sight of that no, hindi na siya makita, but it is there no nonetheless no. So infrared no, I think no, infrared is always equated to something like detecting something no nga may ano na, may warmth ng atong lawas no. So there are, I think no, there are infrared goggles to know no the there are devices that are able not to see no even in the dark by using some infrared goggles no. And again now they use the technology here no, the energy in this end no are lesser no. So if you look at the energy the how the energy behaves no, so if the wavelength is much longer no, longer wavelength no, so longer wavelength will have lesser energy no? But its frequency here no is kind of low no, low frequency no. Magsiling ka nga low ang frequency, then the ano ni, the distances no between your waves are farther no? Okay, so no? So this is our spectrum, and we'll be seeing quite a number of this spectrum no. So as you go to the left as well no, the energy there is increasing no, and you'll realize that some of the waves here no are used in some medical fields no, as you go from the center to the left no. And I think no, they are used in some medical fields no, like to treat cancer no. So there are people that I've heard no that have cancer in their somewhere no, in their face or during a parts ng ilalawas, and it's treated by exposing no that cancer cell no in some radioactive no ano ni material no, and no to treat it no. But sometimes the good no, good cells also of the body are affected no, like maybe the bone here no, and because of that ano ni ginabulong no, including ang damage nga gina-create sa good cells no. So but however no, as of today no, amo na ang mga gina-apply or ginagamit nga way no, of treating cancer no. So they sometimes use exposing it no, to radioactive materials, or they call it I think no, nuclear medicine no, nuclear medicine. So electromagnetic waves no, so once you let it pass through a glass no, then we see that light there no kinds of bend no, and it moves to different directions already. So it has wavelength again. Wavelength is points that are again similar or in phase. So they move together. So from two crests, you can get a wavelength, or between two trough, or you can also identify a point at the start of the wave here up to where it ends. And you'll realize that a wave that is transverse will simply repeat again. So you'll see that this wave starts here and then it ends somewhere here. So the start and the end of the wave is also considered as a wavelength. Now the height or the amplitude of the wave here so it is both either going up or going down. They will have the same value. That amplitude will tell you of the energy that the wave is carrying. So the greater is the height of the wave there, then the more energy it possesses. Or if it is lesser in height or amplitude. So wavelength. So what we don't see here is frequency. So but in a given period of time, if you count how many waves are created, then you can see or have also frequency. So that's the number of waves in every unit of time. Ang frequency natin. And the unit of frequency is of course in hertz. Now the time for one wave is known as the period of the wave. So if you determine how long it would take the wave to create a single vibration. So that's what we call as the period of the given wave, and usually that is done in seconds. So here is our transverse wave. And the thing about electromagnetic wave is that it can reach the earth from the sun. And we know the kind of wave that is emitted by the sun are electromagnetic radiation. And they don't need any medium. There's no need of water or air there for that wave from the sun to reach us. Now here is the electric field again, and we've been mentioning that the electric field, once it's there, they will be moving ang magnetic field in a perpendicular manner. So 90 degrees from one another, the electric field and the magnetic field are created. And again, this idea was brought about by James Clerk Maxwell. So as the electric field is moving up and the magnetic field probably, or the magnetic field is moving perpendicular in the other direction. Now the third direction here will now be the way or the direction of our wave. So the wave will be also moving perpendicular to these other two directions. So so it will propagate itself. So this is a self-propagating wave. And again, the magnetic and the electric field will not need any help from any form of medium like water or air. So it is a self-propagating kind of wave. So electromagnetic waves travel at 300,000 kilometers. So if you express it in kilometers per hour or per second, that's 300,000. If it is in meters, then that is 300 million. 300 million meters per second. If you express it in meters per second. So it can go around the earth 8 times. That's how fast light is traveling. And I believe until today, we consider light to be the fastest thing in the universe. Now I think we introduced this concept, the speed of light, because we will use that idea in Einstein's theory of special relativity. So we introduced this concept of the speed of light. Now waves or particles. What is electromagnetic wave? Is it does it have particle? So ang aton wave, ang aton electromagnetic nga radiation is both a wave and a particle. And ang ining particle again, we call it as photons. And the photons that comes from our light, no, can affect, no, electrons. So there are times when we beam, no, this light, no, and it will cause electrons to, no, go in other directions, no. So if light is merely a wave, then it will not affect, no, probably the movements of electrons, since we can think of electrons as some kind of a particle also, no. But again, no, because they bombard or strike, no, the electrons has this what they call, no, the photoelectric effect, no. Naga nagaka-excite ang inyong electrons, and then they kind of, no, move, no, in a different directions, as if may ara nga collision nga natabo, no. Okay, so electrons gets knocked off, and again, no, that's where the concept that light is not merely a wave, no. Somehow in light there's particles that are not, no, wala galing iya massless nga particles, no. We call as, again, no, photons. Now, as I've said kaina, may ara to nga black surface, no. I forgot the the term, no, that they were using for that color, no, that it will absorb, no, these photons, no, 99.9%, no, or even 99.999%, no. A very small amount of photons lang ang hindi ma-absorb, no. And because of that, no, you will see the surface as completely black, no. Now, what they were doing actually, no, gin-invento nila is to hide, no, to hide this very bright nga mga I think, no, it's a diamond, no, that when diamond is struck by light, it will create a reflection, no. Mayara siya i-create nga reflection or may light nga naga-bounce dira, no. And that light, no, that ang brilliance ang isa ka kind of stone, no, like diamond, is unique, no, to that mineral, no. As a way of knowing even, no, sa diamond, kung diamond gid man na siya, there are those, no, nga naga-check siya na by putting it in the presence of light, no. Kagang iya nga pag produce ng light, no, mabalaan nila na this is really diamond, no, because of how the light behaves in that mineral, no. Now, they would want to keep the diamond, no, para nga hindi makita ang iya reflection, that they invented that kind of, I think, no, color, no. And again, no, it after the invention, no, they were able to absorb, no, a huge percentage, no, of photons, no, that is coming out of our, no, of that mineral, no. Now again, now not again, no, light is not merely a particle but also as a wave. So we have eventually, no, the dualistic nature of our light, no. Here's the different wavelengths, no. So longer wavelengths, this one, no. So you notice the starting point and the end point of the wave on the left side, no, are far. So this one has very, no, long, no, wavelength, no. Ang radio waves, microwaves, no, have longer wavelengths, no. But the visible light, which is found somewhere in between, no, which is in nanometers, no. So may ara kita to value kay nga 400 to 700 nanometers, no. That again, no, it is found somewhere in the middle, no. This is the only portion of the wavelength that is detectable by our human eye, no, the visible light. Below that, no, or the shorter ones, no, which have higher energy, like ultraviolet, no. So you notice ultraviolet. Where do we apply ultraviolet? We can sanitize, no, a surface. Okay. Recently, I just have this dentist appointment, and it's very, very common to some clinics, no, like the ophthalmologist also that I go to, no, when I have my eye, no, check up, or my dentist, no, when I have my checkup in my my teeth, no. Ang mga bangko na ginausar, no, they kind of let, no, some UV radiation, no, go through it, no. Because again, no, UV or ultraviolet does not have no this harmful radiation, no. Wala siyang radiation, I mean, no, nga pwede nga mag stay, no, like that of X-ray, no. So ultraviolet is simply, no, it can kill, no, the ano na kung ano nga particle, no, like microbes, no, or viruses. So you can run an ultraviolet, no, on a surface to, no, sanitize it, no. So again, because of the higher energy that ultraviolet, no, has, no. Now I think there's an ultraviolet ray that comes from the sun, no, and we could have, no, an exposure to ultraviolet because of the ano ni, the holes in our ozone layer, no? As they say, no, there's that our ozone layer is damaged, and because of that, no, we kind of what, no, put some sunscreens, no, whenever we are having, no, a time in the maligo kita sa mga baybay, no, so we put some amounts of lotion that has sunscreen in it, no, so that, no, we can protect our skin from, no, from being damaged, no, like skin cancer, no, developing, no, because of the ultraviolet radiation that we can absorb, no, if we expose ourselves to intense amount of sunlight, no. So again, no, these ones on the right sides, yara ani sila yung tag-as nga ano ni energy, no, dalag ko ano ning energy nila, no. So again, no, it's called as a spectrum because it consists of several things, no, inside it, and light is just merely a portion of the electromagnetic radiation, no? So still, no, more on this electromagnetic spectrum, no? So some things that we use our electromagnetic radiation. So we have your microwave, no? Maybe we can use it in our phones, no? So we have a line of sight, no? When we say line of sight, it is a straight ang iyang pag-project is in the same line, no? Kung curve ang surface, or there are blockages, no, may mga structures that come in between, no, structures, then ang ining wave may not pass through them, no, they will block, no. So we call that as line of sight ng mga signal, no. So you avoid interference in between, so you will have a smooth flow of the signal, no. So no, so you can have, no, this one, no? So a lot of these towers actually, no, are producing, no, some radiations actually, no. And I'm reading now lately the effect of this microwave, no, or the effect on plants, no, sa sining mga ano ni mga towers, no. And in some readings that I've have, no, over the weekend, I've realized that why do they study plants over animals? Because usually, no, animals are not stationary, no. So if you will study the effect of microwaves, no, on animals, no, or on people, sometimes we are not always in the presence of this waves, no. Kaya pwede kita kasaylo, pwede kita kalakat, pwede kita aton ibilin aton phones. But plants basically, no, are not movable. They are there always, no. So they kind of check, no, the effect, no, ano ang ma-observe sa mga plants that are, no, near, or trees, no, that are found, no, in these locations nga may mga amo nga mga towers, no. And I find, no, I think, no, in one abstract that there's a significant, no, damage to these plants, no, that are exposed to this one, no. So maybe, no, over a long period of time already, no. So the studies, no, nga ginakandak nila are not merely in a matter of a short number of months, but years, no, because maybe plants are there, no, before even ng ini nga mga structures na construct, no. So again, no, one way to, no, maybe, no, if you go into research, no, in the future, you may be interested, no, to study, no, more of these waves, no, how these waves are actually, no, affecting our surroundings, no. So again, no, one way to have, no, a study that you will see really an impact is on plants, no, because plants do not move, no, they do not transfer, no, they are there, no, 24/7, no, all year round. They are exposed, no, to whatever, no, is being placed near them, no. So I'm gonna also impact on surroundings, no, of these waves, no. But nonetheless, no, there are no studies that are really saying, no, that these structures are harmful to human beings, no. But they've seen, no, some effect of this, no, on plants, no. Now radio waves, no, we have the longest wavelengths, no? Ano yung mga lagba nga wavelengths, radio wave, microwave, no? So as we get lesser there, no, sa aton nga spectrum dito, then we go near to ultraviolet, no? So upod na sila sa aton nga, I don't know, sa aton gali nga infrared, no? Sila na da, no? Those are the spectrums before the white light, no, or the visible light. Now we use this, no, to transmit, of course, no, sa mag broadcasting, no. So we have these longer wavelengths ng mga frequency, no. So GPS probably would use this, no. So global positioning system. So for your radio, no, so we kind of pick up, no, the radio waves kun, of course, no, kun aton nga i-tune ang aton radio to match, no, to match the ano ni to match the resonant frequency, no, of the broadcasting wave, no. So ang mga tawag lang carrier wave, no. So the one that comes from radio station, carrier waves, you have to match that frequency, no, to be able to listen to your device, no. Mayara kada nga device nga radio, no. Now other functions, we have imaging functions of light, no, of this wave. So we have the magnetic resonance, no, MRI, no. So I think, this is very costly, but this is very effective, no. In some people nga may ara nga something happens, no, inside their brain, no, that they have to scan, no, do some kind of a scan, no. So imaging, guys, no, allows or keeps, no, doctors from actually, no, slicing or opening up a person. Kaya they have to check something inside there, no. So imaging like X-ray, no, which is one of the earlier, no, types of scanning, no, is proven to be very, very useful to us, no. Kaya the doctors does not have to open you up, no, to know what is not working, no, or what is causing the illness. Then they can simply scan you, no. May ara man nga sa gina-check ang heart, no, and all these things, no. So imaging, no, is used both, no, in the industrial field and in the medical field, no. I think I've told you, no, about the function of scanning, no, in the industrial field, no, like again in structures like in works like welding, no. You have to know the quality of the welding, no, process. Was it done properly, no? Was the welder really, no, says who he is, no, like ginambalida nga nami siya nga welder, but how would you know, no? Maybe the outer part of what he worked on is good, but maybe, no, inside the welding process hindi nami ang pag-ubra, then they don't have to open up the work, but they just simply do some scanning, no, to know, no, whether the internal welding process was done well, no. So when it requires or need, no, to be done again, no, may ara nga back job, no, or they will redo the process of welding, then they have to support it with what the image, no, of an X-ray scan, no, showed, no, kung laway ang obra, no. So again, no, ovens, no, so we have microwave there, no. So we transfer the wave into the food, and we will notice that it gets cooked, no, or it gets warm, no. So kung halin sa ref, laway man ang kanon mga bugnaw, no. So initon mo siya, no. So anong matabo da? The thing that you have to place there inside your microwave will absorb, no, the waves, no, that is being produced by your microwave, and therefore, no, it will get out warm. Pero na notice nyo, iya suludlan or ang pinggan hindi iya init, no. So materials that do not absorb, no, microwaves are usually, no, placed together with this food, no. Like may ara na nga microwavable nga plastic. So hindi na siya maapektuhan. Ang pagkaon lang, no. Pag uyat mo sa pagkaon, init na, no. But I think, no, there are things that you have to observe when you are using your microwave. Like you don't close, no, like a container, hindi mo siya pag-seal, no. If you seal it, then you'll notice nga magka-problema ka na, no. It will crumple down or ma-decompress na siya, no, kag hindi na maabrihan, no. So when you use a container that has food inside, do not seal it, no. Put some opening, no, before placing it, no, in the microwave, no. So some things that, no, you may actually experience, and you don't have to copy it, no, from other people to see really, no, if that's true, no? Next is radar, no. So radio detection and ranging. So we use radar not to know whether our airspace has been invaded by other countries, no, whether so ang Philippines, no, kumiyara siya nga radar facility, no. It can know kung may mga mga other nations nga nagasulod sa aton territory, no. Before they could even reach, no, the Philippines, we can know kung ara sila within our area, no. So again, no, because if we have, no, this radar system that is in our country, no, around our country, no. So without even watching all areas of the Philippines, no, we can know where they are coming, no, kung may ara kita nga radar system nga nami, no. But other than that, no, we can also check, no, whether one vehicle is also overspeeding or not, no, by using this radar gun, no. So ang police, may mga amo na nga police nga may mga dala nga radar gun to verify, no, nga ang imo nga paggamit sa salakyan mo, you are beyond, no, the speed limit that is set on the road, no. So you use some infrared, no, some radar, no. Infrared, no, invisible electromagnetic waves that are detected as heat. So human beings, of course, no, we emit some infrared because we are alive, including this animal, no. So there are portions of this cat, no, that is producing amounts of heat, no, because this cat is alive, no. Maybe if the cat does not produce any more heat, then we could not detect this thing, no. So the infrared goggles, no, the goggles that are used in some by some militaries, no, are the ones that detect, no, this heat in human beings. So they are able not to see, no, people when they move, no. So infrared is below the red, no, the red color of the white light. So that's just a little bit lesser than that, no, a wavelength, and therefore now you have your infrared. So it has what, no, low energy, but it has its amount of heat is quite high, no. Now I think, there are some devices before that uses infrared, no, to transmit, no, data. There's way back, no, some devices that use infrared, no. So you just like microwave, no, we can also send no our voice no or our text message over microwave. Infrared no was also used no at some point no. But somehow no do wala na lang ni siya nato makita subong no. So things about infrared no, so if something is producing heat there no, then it can be detected no by the infrared goggles no. So visible light no, shorter wavelength and higher frequency no than your infrared no. So the longest wavelength in the visible light are those that are colored red no. Ang color nga red, manotice naton, it's very very attractive no. Children or babies no in the crib, ang baby nga ara sa crib kon, if you will bring a ball or anything that is colored red, the child no will be fixated no on that color red. Ang mata sang bata dira gina matulok sa sina nga color nga red, because again no, it is very very no striking to the eye of the child no. So amo na no, so that's the thing with red no, it has the longest wavelength no. You'll also notice that next to red is orange no nga color, and usually ang mga bayo sang mga rescue team no, ang ila na colors ang ila bayo is always orange no, because orange is next to red na color, and it is also no having a longer wavelength nga maskin sa layo ka no, kung nagasuksok ka sang bayo nga orange makita ikaw no. So mga rescue no or ang ara sa dagat na bala no mga crew no sang barko, nakasuksok na sila sang ano na no, sang orange color no. Yes no Dexter, it's time already. I think no one of the things that ang mga crew sang barko no, when they are on duty, they wear orange, I think no, overall nga suit, because again no, in the event that they mahulog no, they will man overboard na tawag nila, madagdag kada no, and supposing may nakakita sa imo no nga nahulog ka, so mahingagawon kada nila nga i-rescue, then you can still be seen no nga nagalutaw-lutaw da no. So pwede ka nila tagaan sang life raft no, para nga madali ka ma-detect. Kung sa dagat na guys no, kag mabalod, kung magsaka ng balod hindi ka na ma-detect kung diin ka dampi no. Okay? Okay lang na yung dagat nga makita natin that is still no. But in the open seas, mabalod na no. So if you are floating no, kag natabunan kada sang iban nga mga balod no, kay nagasaka panawag ang balod, ang mata naton may not be able to see no that you are still nearby no, because of the presence of the waves no that may cover no the eyes of the people that are looking for you no. I experienced one time when I was riding sa isa ka barko no. It's very common in my time no nga nagasakay kami sa barko over planes, because that's the one that is affordable no, that's the one that is always no nga ano na nga may biyahe maskin gabi no or what no or barato. That at one time no may tao nga actually mag-asawa sila no, ang husband no, I don't know kung nagalain ng iya ulo, and for some reason gulpi lang siya naglumpat no, naglumpat siya sa tunga sang lawod gabi no. And ginpangita siya sang barko, ang barko nga ginasakyan namon nag-uyang gid sang hours no to search for him no. Di amako mo na no gabi kag naglukso siya. So ang barko no again no naka-maneuver, pero it takes time na nga naka-maneuver, nagbalik siya sa ginagyan niya. But the whole night, the whole time nga pangita siya no, wala gid siya nakita sa dagat no? So amo na no, if you don't wear anything that is visible, most likely hindi ka na makita sa lawod no, especially at night no. So nobody will jump no kung hindi ka na nila makita, ipangitaon ka na nila, and nobody will search for you nga panaugan kakag pangitaan ka da sang barko da nila nga gamay no, para nga i-search ka, no no. ilabyan-labyan ka lang sa barko kung maglumpat kaya they will not no endanger their personnel, no, but they will give time, no, maybe hours, and then again, no, the whole trip apektado na, no, because of that, no. So ang arrival time nyo pag abot nyo sa pier, no, it will already be late kay that one happened, no, in the evening, no, an eventful travel, no, like what people would say, no. Okay, so again, no, orange, red, no, these are the longest wavelengths, and these are the ones that are really caught by our eye, no. Dali gini siya ma-attract sa aton eye. Then the purple or violet is the shortest one, no? Just like I think after this is the ultraviolet already, no? Ultraviolet radiation, no? So Roig Biv, no? If you remember that one, no? So we think that there are only 7 colors, but in reality, no, there are a lot more, no? So Roig Biv, no? Red, orange, yellow. Then this is what? No, green, no? Blue, indigo, violet, no? So if you let light pass through a glass, then this is what you will see, no? So light will be dispersed eventually, no? Now next to the violet color is ultraviolet already, no? So it can cause skin cancer, it can cause blindness, no, if you expose your eye, no, to too much, no, of this UV rays. I think there was a time when people are what, not tanning themselves, no, by going into a chamber like this that has UV, no, UV radiation, and then they will cover their eye, no, with some goggles that is shielded, no, from UV radiation. Kaya nga to na nga soft tissue nga mata pwede ma-damage na, no. So again, no, you can tan yourself, no, with some levels of controlled amounts of UV radiation, no? Or sterilizing, no, some equipment. So we have some UV scanners, no, mga bakal na to nga do mga tube na bala, no, and then they can scan a surface to kill, no, some microbes or microscopic, no, nga mga objects, no. So it has high energy, no, it can kill bacteria, it can sterilize, no, some surfaces. So it's very sanitary, or do kanami lang kay you don't have to spill a liquid, no, to a surface, no. You simply scan it, no, with some amounts of this light, no. But of course, no, we see also some skin cancers, no, as a result of UV radiation as well, no. So but I think, no, not all skin cancers are a result of UV exposure also, no. Nowadays, no, we don't really, no, know, no, some causes of why we have that, no. Some people are so attentive to their food, no, they don't smoke, they don't drink, no, and everything, but still, no, they acquire cancer, no, for some reason, no? So I don't know, no, this thing about cancer is uh it's a sad thing, no, but sometimes, no, we could never really, no, avoid or identify, no, the root causes of these things, no. Vitamin D, guys, it's good for our immune system. So where do you get vitamin D? From the sun, no? But not, of course, too much. So I think when we expose ourselves to the sun, vitamin D is produced, no, because of the molecules that are created in our body. So we can actually produce vitamin D when we go out, no, and expose ourselves to some good amounts of light, no. Hindi lang nang daw sobra-sobra na gid, no. So vitamin D, no, is good, no. Ang aton immune system again, no, works better if we have amounts of vitamin D in our body, no. Now, to some people who are not able to get vitamin D from the sun, no, it's not actually not the vitamin D from the sun, but there's a reaction that happens to our body whenever we are exposed to ultraviolet, no, ultraviolet rays, no. So when we get ourselves stunned, no, for some good amounts, then we can create, no, our body can create vitamin D, no. But if you cannot, no, get vitamin D from the sun, you can get it from fish, no, cod liver, no. Ang mga cod na mga isda, they all or they have good amounts of vitamin D, no. Ano pa again, no? I think ang boiled egg, no, an egg, no, if you eat one or two, no, but not, no, hindi mo lang paghimuon man nga daw lawig-lawig damo-damo na gid, no. It will give you, no, some amounts of vitamin D as well, no? X-ray again is another way of getting an image, no. It has high energy, so we are very careful, no, in exposing ourselves to X-ray. So usually, no, we don't really go to or have X-rays, no, now and then, no, liwat-liwat, no. Let's say for every day, no, nagpa X-ray ka. I think you have to ask your doctor about it, no, because exposure to X-rays, of course, no, you will absorb some amounts of radiation there, no? So these are high energy waves that, again, no, it can damage also our body, no. But there are purposes for that in medicine, no, in the industry. I think, no, in the industrial field, no, you can check a structure if it's good or not, no, internally by bringing, no, a portable X-ray machine, no. And astronomy, no, I'm not really familiar with how to use that in astronomy, no, but in medicine you can expose some cancer cells to X-ray and somehow, no, treat it, no, if it is, no, still within the level that it is treatable, no. So may ara na nga ano na gani stage ang cancer, no. I think the stage that is worst is stage 4, no. So on the earlier detection of cancer, no, some people undergo radiation, no. Maybe one type of radiation would be X-ray, no. Okay, so we can absorb it, no. So you notice that, no, when you go into X-rays, no, may arada sila technician, we call it a radiologist or radio technician dira, no. Nagasuksok na sila sang do covering, no. They go into one area where there's a glass, no, and there's a protection there because the X-ray radiation will not penetrate through that separation, no. So they are shielded, no, somehow from radiation, no, when they are in that chamber, no. So masulod ginada sila before they will, no, they will activate the X-ray machine, no. So kita yan, no. So if you are not knowledgeable about that, you can also absorb some amounts of radiation if you will be present there, no, sa naga-X-ray sila, no. So for you not to absorb the radiation, then you go out, no. So like this, no. So they wear something like this one, no. So it's made of lead, no. Tingga. There's lead there, no, because lead will prevent you from absorbing, no, radiation, no? So he covers his body because ang imo internal organs are the ones that are really prone, no, to damage, no. So they kind of shield your heart, no, your kidney, no, your liver from absorbing, no, radiation. So again, no, X-rays also can know that there are cracks inside, no. So even if it appears, no, that it is good outside, you can check internally, no, if it's structurally sound or not, if there are damages inside, no. So let's say naglinog, no, it's a strong earthquake. Now what they will do, maybe if you will let your engineers, no, ano na, no, check, no, the structure, if it is still sound, then maybe, no, they will bring this X-ray devices, no, to know kung ang crack na nakita dara sa inyo haligi goes into, no, the whole column, no, if it is still safe, no. Then we have your gamma rays, no. So these are the ones with the highest, no, energy. So I think, no, very harmful to us. So they have the shortest wavelength, no? And the greatest amount of energy. So we don't expose ourselves to gamma radiation. But I think, no, gamma radiation, if they will control it, no, can also be used to kill cancer cells, or they can be used also, no, to sterilize a surface. But I think, no, ginasetto lang natin sa ultraviolet because it's less, no, ang energy sang ultraviolet, no. But again, no, gamma rays, no, can be very, very harmful, no, if you are not able not to control it, no. So si Hawk, no, so sorry, no, for that image, no. Nuclear explosions, no, emit gamma rays, no. So when you absorb this, no, I think, no, you will have organ, no, damage. If you will absorb all that, and that's why when there are imminent danger from nuclear explosion, then you must know how to, no, manage yourself. You have to be shielded, no. You have to go indoors as others would instruct, no, if there are things, no, that are really, no, producing nuclear radiation, no? So here's some of the summary now of our electromagnetic waves, no? And then again, no, you can go through all this, no, if, no, you have time, no? Okay, so no? So seeing color, so we see red because it strikes, no, light strikes the surface, but the ones that reflect and goes to your eyes, the red color, no? The rest of the colors are absorbed, but only the red one, no, is being reflected, no. That's how you see this red color ng apple. Now this one, no, this is a pepper. So green, no, is being reflected, so the rest of the colors are absorbed, so therefore you will also see, no, the color red, no. But I think, no, let's check the time, no. Okay, so we will run through, no? So since it's almost time already, so let's run through with the remaining names that are not yet checked, no, a while ago. Christopher Balderas.
Present, sir.
Brian Blanco. Not here. Jose Robert Cordova.
Present, sir.
Calexo Corpus.
Present, sir.
Ale Dilmendo.
Present, sir.
Kent Dipakakibo.
Present, sir.
Pauline.
Present, sir.
Gloribel.
Present, sir.
Alvin Guillermo. Alvin.
Present, sir.
Hulitan Jason. Jason. Not here. Labaniego Alisa.
Present, sir.
Charles. I think Charles is there. Benjamin Palma.
Present, sir.
Dexter is present. Ralph Rafinian. Ralph, are you there? And Christian Tamayo. Christian, wala. I will repeat, no, those that are marked red. Christian Tamayo.
Yes, sir.
Ralph Rafinian. Ralph, wala. And si Jason Clyde Hulitan. Jason, are you around? And last is Brian Blanco. Anybody? Ang tatlo ni, no? Ara si Ralph.
Opinion, sir.
Okay, thank you, Ralph. So Clyde and Brian is not here, no? So for today, I think that's all, no? So because it's already, no, 10 minutes before the time. So God bless you, everyone, and see you in our next meeting. But please prepare for our quiz, no? I may give a short one, no, next meeting or on our asynchronous time, no? So God bless everyone, no?